This is the Empower Podcast, released April 5th, 2021, Episode 537, Firmware Deployment and Troubleshooting with Akbar Dhanaliwala. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
Hi, I'm Akbar Dhanaliwala of Logger Data.
Hey, Akbar, how are you?
Pretty good. Yourself?
Good. Logger Data sounds like we're going to be talking about beer and data, but I already know it's not. So what is it just for brewing beer, or is it something else?
It's for something else. It's a testing platform. And initially our initial idea was going to be like a wireless serial logger. So we were calling it the Logger. And then internally, like someone said, well, why don't we call it spell it like with an A, like the beer. So we started calling it Logger like that. I mean, even though it sounds the same. And then, the idea grew, and what it became much bigger than just like a wireless serial logger. But we kept the name. And then when we, decided to turn into company, everyone's like, well, it's, Logger Data's, the URL is available, which is always,
there you go.
First thing you need to figure out.
Yep.
So we just stuck with it. And, so far it hasn't been no one's been too confused about what we do. So that's been good.
Good. Yeah. And I mean, you have a long history of working in embedded projects and things like that. So let's start with what you don't like about logging data, and what were you trying to fix up front? Like, why is this a problem at all?
So I've been doing embedded systems for a long time, about 15 years now, I think. And I actually love embedded systems and writing. I actually like writing. I know a lot of people aren't like, C has a people fall over
some distractors, perhaps. Are you saying
exactly.
The Rust crowd doesn't jive completely?
No,
with the C
exactly.
crowd? Yeah, that's odd.
But I always loved the like that first getting that first program running on a small micro, especially when I started, was 8-bit picks, and getting that first LED blinking, and I love it. I love the whole process of turning something that was inanimate into like an animate object into something. And so early on, a lot of it was just like cool, like, oh, I'm going to do this cool little like project. And then, but once you get into like launching real products, that's when you have to like actually have things have to always work, and that's where you start doing a lot of testing and all that. Like you start learning what it takes to actually launch a product. And all of a sudden it's like what I found to be fun, it turned into these like super tedious chores. And I think this is particular to the embedded world, because you are dealing with hardware. Getting access to the thing you're making requires physical contact, right? You need to like solder wires so you can access your JTAG header, and you need to find out where your UART pins are, and again, probably solder wires to it. And sometimes those wires break, and you're like, am I debugging my code, or am I debugging my bad soldering job? So basically, I think sometimes it's probably because I'm a little lazy. I don't like having to always context switch. But it's like in the embedded world, you're always context switching, right? It's like, oh, let me get the scope probes out. Let me get my debugger out. Okay, let me see if I can, maybe like I'll just run it overnight and have like a UART log, and and all those things require a lot of setup, and getting the data is kind of sandbox inside, like whether it's a serial terminal or your oscilloscope. So in general, I was just frustrated how, like, when I'm debugging a bug or whatever it is, there's so many different things I need. I can't just sit on my keyboard and basically command tab into, okay, let me check this. Like, access to that data is it's tedious to get. And I have friends who write software, and they literally can sit on a couch anywhere and do like the most sophisticated things, web applications or whatever.
Right. They're like writing tests, and they have all the hooks in there so that they can do both sides of it effectively.
Exactly. They've got everything they need right in front of them.
Yeah.
They get to be lazier, but the big win is they get to be more efficient. Mm-hmm. And I felt like, I was like, oh my God, how cool would it be if I just had access to the data I needed when I'm trying to solve, a really hard problem. And then, another problem, issue I always had with embedded was I do like, laptops have really come into their own over the last 10 years. And I feel like embedded engineers don't really get the full advantage of laptops, because we're kind of stuck to our hardware, which tends to be stuck in the lab.
Mm.
And I was like, wouldn't it be cool if I could like walk through my code from a couch? I keep coming back to a couch. Like, I really obviously like want to basically just sit on the couch and develop,
Yeah, yeah.
or like, or just be able to like not always be in the lab. Maybe it's a nice day out and I want to go to a park or something. Just like, who knows what it is. And I again, thinking about my software friends who could do that, and most of them don't do it, right? They still are also at home,
Sure,
or
sure, sure.
but they do still have that freedom that I always kind of wanted when it came to developing. So
Well, I wondered if there was a tie-in as well to the fact that, I mean, so you have a mechanical engineering background, so you're doing like robotic
right.
kind of stuff too. So I'd imagine sometimes it's just not even a possibility because your embedded system is rolling away from you. You know.
Exactly. Sometimes, I mean, sometimes you just have to be there, right? Like, I remember
Yeah.
I was once working on it was like a solar panel robot cleaner, and
Yeah.
sometimes it would just like I was helping writing a controller for that, and for whatever reason, sometimes something would go out of whack, and thing would just run down the line, down the panels, and there's no way you could do that from
That's right.
from a couch, not right there on where the panels are.
Is it like the safety switch is like the debugger getting unplugged as the robot
That
flies
actually
away from
happened
your
one
laptop?
time. Like, I didn't think it was going to turn on, and I was like, I had my J-Link, via USB, and it yanked my computer off my lap,
Oh wow.
because I'm like kind of like walking with my computer behind the robot as it's like trying to like, and they had like a little like small little like test rig inside of a inside of a warehouse. It wasn't like out in the solar.
Right.
But yeah, so like, even in when you are co-located with the hardware, I was like, it's still annoying that I have to like, my computer needs to be attached to the hardware, right? Like, I was
Right.
like,
Yep.
so that would also be a huge win if I could still have access to the hardware, but not have to like worry about, test harness, wire harnesses that make sure I don't like lose my computer as the robot's running
Yeah.
away from me, stuff like that. So
So why doesn't J-Link have this sort of thing? I mean, I guess I'm wondering kind of what else is. I mean, I'm sure you've seen a lot of this marketplace too. So like, why doesn't J-Link have like a wireless debug link or something similar?
So they do. So J-Link actually, a lot of these things, like, oscilloscopes have like, you can plug into the Ethernet, and J-Link, all these things kind of have a feature that kind of works. I think it's called like, I forget it's not top of my head, but they do have a thing you can install, and it like basically, but you need a full on computer at the end. So it's like, so
Mm.
basically, I think the way it works is you have your like, your J-Link probe, and it plugs into a computer, but it's still a computer, and then you can like,
Uh,
basically pipe into that computer and control your J-Link from another computer, and so both computers are
oh
running
yeah.
some J-Link software, and
Yeah, I've seen that before. So it's like instead of a USB, it's like a IP endpoint, right? It's just like piping it over an IP address.
exactly. So there's still a USB in the mix, but it's not to your computer. It's an
Right.
IP link.
Okay. So it would require you to like really miniaturize a computer then and be running like a Nook or even a Raspberry Pi, something like super. Well, I don't know if you can get J-Link working with the Raspberry Pi, but like something super small, hopefully, that's then sitting on top of your robot, right?
Right, exactly. And you actually can get J-Link. We actually know this now. You can get J-Link working with a with a Raspberry Pi. They
Oh,
luckily
cool. Okay.
do have an ARM build. So like, so J-Link has a thing, and there are ways to do it if you know, basically, if you're somewhat good at DevOps, or like,
Hmm.
networking, and when it was never my forte. Like, I was never like, like, I can use the internet, I can get on a browser, I can, and I know
Sure.
probably more than like a non-engineer.
A Mechie that also knows electronics and firmware. I think you're you're doing a couple things there. So I think you're good. You're good. You don't have to also do DevOps stuff, I guess.
Exactly. Yeah. So like, I'm not, not totally like clueless when it comes, but I'm not, like, it wasn't something I also wanted to like, really dive into. So I never really took advantage like of setting up some of these remote things. But so yeah, so that was kind of like how I was like, my kind of like my things, like, some of this stuff exists, but it's not user friendly, if you know what I'm saying. Like, it's almost
Yeah,
like, you could,
yeah.
before Dropbox, you could go to Amazon and buy a networked hard
And a
drive, and
knack.
it's like,
Yeah.
you just plug it into your network, and you put in your closet, and then you've got the thing that basically Dropbox gives you. But it was, if for whatever reason it didn't get online, or tomorrow, like one day it just wasn't there, you're like, I don't I don't know what to do anymore, right?
Right, right, right.
So I feel like we were trying to like solve that problem of like, how do we make it so that you don't have to think about it? Like,
Mm.
you get this, ability to like remotely talk to your hardware, and you basically get access to it, so that testing becomes really easy, and you don't have to think about the DevOps problem that's associated with it, because it's getting it working one day is fine. Getting it working for your whole team forever is like a whole different class of problem.
That's right. Yeah, I agree with that. Well, I want to hear more about that, but I also want to hear some more war stories because you have about eight years of experience at your consulting company, and I think that there's got to be more war stories in there somewhere. So,
Yeah,
you,
there's definitely, especially
yeah.
when it comes to testing.
And how would you define testing in this case too? I mean, are you talking about production tests? You talking about just like engineering tests? Where are you at in the process usually?
All across the board. So like,
Okay.
like, basic debugging where it's like, hey, like it's not doing, why isn't the LED blinking? So you set a set point and you're reading registers, to like QA testing of like, hey, like, okay, we're gonna, like it's a small run, but maybe we should test this like, on a bench for 2 days or a week or whatever, all the way to like MPI and like, actually introducing it to a
Yeah.
factory, across the board. None of those like different phases of testing where they were like, at least this, someone solved this, this phase. This part is easy.
It's all so easy now.
Yeah. At every point I was like, well, there's always challenges, especially in the embedded world. As these, like I said, this back in 2004, I thought MCUs were amazing, and in the last 16 years they've gotten even more powerful. Right, you can get like an
Hmm.
M7 for $4 and get 400 megahertz of processing power with like tightly coupled memory and a gazillion per. It's just crazy what you can do for not. And
Oh,
so,
totally.
but the side effect of that is that there's more ways for you to like really blow off your foot, as it were. Like it's so powerful that
Yeah.
without
Yeah.
testing you really can't find the kind, you can't think through your possible bugs. You really have to test it and see where you're going to find those really weird corner cases. So yeah, so I started consulting right after grad school, more kind of as just like a way to like pay the bills. I was really excited about smart homes. It was me and a buddy. We didn't know what we were doing, so we kind of started this company, Pokebore, to get just do some side gigs, and that really quickly grew into like a full time job for us. And one of our very first client was Solar City.
Oh, wow. Yeah.
They had just started. They had just moved into their new office, which wasn't like their eventual office, but it was like their first real office from a garage or whatever. And they put out a posting looking for someone to like a team to help them build a wireless system for their solar panels. So they had solar panels, and they were getting into the solar panel installation business. But what they wanted to offer their customers was a way for their customers to see like real time information on like solar generation. So like you could go online, you can click into a portal and say like, oh wow, like I'm producing this much megawatts of energy, or whatever.
Yeah.
And no one had really done that before. And they were trying to figure out how to do that in a cost effective way without running like Ethernet cables from the roof, and basically how do we make the installation? Because their whole game is like, we're an operations company, and making installation really really affordable. So how do we give users this nice feature without adding a bunch of cost to installing this monitoring system?
Yeah, I'd imagine that there's also like a marketing aspect there kind of built in on the back end too. It's like, because if you show people that they're saving money and that like, oh, you're cool, like solar panels are doing all this stuff. Like one of my friends is sharing on, he just installed his own. He's just like sharing on Facebook, like, hey, look at our energy usage. Like, this is so
Yeah,
cool. And then
exactly.
like,
Yeah.
yeah, it's like built in marketing too. So that's great.
No, it was a great idea, and we were really excited to do it. There's this new technology that back then, called Zigbee, right? It was that
Hmm.
it was part of the whole home automation stuff. Zigbee was going to come in, and like everything in your house was going to be networked via it. So we got to work with this really cool technology, and so we basically designed that system of there was a bridge that lived in which we designed and wrote the firmware and everything, that lived in the inverter. That's how they got the actual data, and then that bridge talked via Zigbee to a gateway that lived on the user's network in the house. And we also designed the gateway and wrote, and it was like, it was the whole thing. And looking back, it was a really awesome project, but our bid for it was so hilariously low. They must have been like, either these I don't. It's almost like surprising they said yes for how low it was, but they got a great deal. I remember, in terms of like the testing stuff, I remember we were testing the Zigbee range, and we were living in like a suburban neighborhood outside of San Francisco. And basically, like, how do we test this thing? I was like, well, what if I just like get the bridge, we'll power it somehow, and I'll just start walking down the road,
Yeah,
and we'll just
right.
like take like
I've done that test for some LoRa stuff. I'm just like, yeah, it's like line of sight. You wave and you estimate how far you are.
yeah,
Yeah.
exactly. So we started walking, and this is like, it's like early morning, maybe like 7 a.m. And about 10 minutes in, a cop car drives up. He's like, so I'm getting complaints that someone's trying to hack automatic garage doors. And I was like,
Well, you were you wearing a hoodie? Because I mean, like that's how they know you're a hacker.
I was wearing a hoodie. San Francisco,
Oh, you
it's
see,
like,
there you go.
yeah,
Yep, yep,
I was
yep,
definitely
yep.
wearing a hoodie, but it was actually cold, so it wasn't just
Of
for the
course,
style.
right.
And I tried to explain to him, like, no, we're actually testing something, but I'm holding, this like open PCB, like wires everywhere. So I can see how people would be a little a little put off by, someone walking down the street with this gadget, not
Yeah.
really knowing what's going on. I don't know necessarily that like Logger would have solved the, me walking down the street part, but it definitely, like, getting that test set up was annoying. Like, we didn't know how do you do that test? How do you like remotely
Right. Yeah.
send data? And like, we sometimes like we'd say, oh, like, let's change something. So I'd have to run back to the house, reflash it, and then, start the test again. Whereas like it'd be cool if like we could just push that change via JTAG or whatever, like on the spot, and then like keep testing, right? So it's like, like starting from like my very first experience of like, actually like, designing real products, is I was like, oh, testing is annoying.
Hmm. I mean, that's amazing. Like, I mean, that's a big. I guess Solar City was small at the time, but like that's a great first client to have too. And like,
They've definitely helped us build our brand, right? You just say, you just say Solar City, and Elon, even back then, Elon Musk was, people knew who he was, and I don't think he was even really involved. It was his cousin, actually, his two cousins
yeah, right.
co-founded it. So I think I don't know exactly, maybe he was like on the board, chairman or something like that, but you could still say an Elon Musk company at the time. Now it really is, right? Because Tesla bought
Yeah,
it, but
yeah, right.
we would just kind of name drop
I
Elon
mean, yeah,
Musk when
that
somebody,
that that helps. Like that helps no matter what. So that's
yeah.
great. That's great. And so, I mean, how big was that rollout in total?
I mean, I don't know exactly how long, I think they still use it, but
Oh,
I think
great.
we
Yeah.
helped them launch like 1,000 of them, and then they
Uh huh.
hired, that at some point they hired their own like in-house engineering team who kind
Sure.
of took
Yeah, that
over the
makes sense.
design. But I remember like a few years later they called us in because they needed to like fix something or make some changes, and it was still the same. I think they like definitely worked on the firmware a lot because
Hmm.
that's easier to change, but the PCB was still the same PCB, and I was like, oh, okay, like
Yeah.
we've done a somewhat decent job.
Yeah, that's great. That's great.
So I think that, and then I remember years later, my wife's dad actually had Solar City panels, and be like, yeah, I worked on Solar City, and he's like, oh yeah, and he showed me. I was like, oh cool, this is like the gateway we made.
Oh yeah, that's great. That's great.
So that was,
Yeah,
that was pretty
yeah.
cool. It was like a cool
That's really
cool
great.
thing.
That's really great. We have to take a quick pause to ask about what is the what is the genesis of the consulting company's name? Popaport.
Okay, yes. so I went to grad school, Stanford in California, and a year into grad school, one of my friends told me about this thing called Beta Breakers up in San Francisco. And he's like, yeah, I don't really know what the whole story is, but it's you basically get dressed up and you walk and drink a lot, which is not what Beta Break is actually a legitimate. It's a legit race. It's
It's
like one
like
of the
a
oldest
race. Yeah, yeah, yeah.
races, yeah, in the country.
Right.
So
Yeah.
people did definitely take it serious. But then there was also this
There's a
giant like
party scene,
parade.
you'll say, right?
What's that?
A party scene on the back end, right?
Yeah, exactly. And
Yeah.
people really get into it, and they big built floats, and it's a whole thing. But we didn't know anything. We were all new to the area, and so we're like, okay, cool. That sounds cool. It'll be fun. So we were gonna go. Our theme was like since we were all in this like mechatronics program, our theme was like this techno kind of like not LCD.
Mm.
They're actually,
Rest in peace, Daft Punk. Yeah.
yeah, like this
Oh.
like Daft Punk themed. We had like a shopping cart with like an LED like thing that some
Got
circuit
it.
board that
Got
we had
it.
made. Which hilariously, the minute we plugged it in, we saw the magic smoke. So we basically walked the whole parade with like a dead circuit. But anyways, so part of it, one of my buddies also found this like RoboCop costume in a kid's. It was like one of those super inexpensive children's RoboCop costumes meant for like a 10-year-old. But we all, it was like $10. We all got it. So we're all dressed as RoboCop in this parade. And one of our buddies, as part of the thing, had like one of these giant 1980s like boom boxes. And he was just like, carrying it, walking around in a ridiculously dressed RoboCop. And like someone had taken a picture, and it's somehow like the picture of him, and we were kind of like in the background, but it was of him with the boombox, slightly inebriated,
Yeah.
kind of like blew up on one. I still can't remember, like, one of those like early photo sharing sites back then.
Hmm. Yeah.
So we were like, about as like mildly internet like I mean, I wouldn't even say internet famous. It was just like we were, if you search,
You
if you
showed people,
googled,
you pulled up the site and you'd be like, hey, look, that's us.
yeah, if you basically googled RoboCop beta breakers, we would show up, which is kind of like, oh cool, that's like, that's about as that was the extent of our fame, but that was it. But it was like a funny story we told each other, and like, people would say, hey, tell us that
Right.
what was the deal with the RoboCop? So like for a year that was kind of like, our thing, and then
So I want to just pause real quick and see if people like, if they're like, what is this story right now? So I want them to pause and think like, where is he going with this? Because I bet people are going to be like, oh, when you finally explain what it is.
yeah, yeah, that's true. We haven't gone quite far afield now. So finally, when I graduated and we wanted to do the smart home thing, and we started this, but on the side we started the consulting company. We decided like, hey, maybe we'll just make an LLC to help with like, like we didn't really know why it would be better, but people said you should make an LLC. So we said, okay, fine. And we needed a name for the company, and we were just like, what should we call it? What should we call it? And we eventually was like, well, what if we just call it? We seemed a lot like, be the RoboCop. Everyone called us. It was funny was like we became the RoboCop guys, all because of this one beta breaker. Every time we went to a party, because there was like four of us, and we always like kind of like went moved in together. We went places. So whenever we'd show up, be like, oh, it's the RoboCop guys, and I was like, okay, yeah, I guess that's us now.
That's our thing. Yeah.
So when we started the company, we just said, well, what if we just made it, RoboCop backwards? And again, like, the URL was available at pokeball.com, and it sounded kind of cool. So we did it, and never thinking it would grow into anything more than just like like this thing that we needed to do some side consulting. But it grew into a meaningful business.
Yeah. Yeah.
And the greatest thing would be when people wouldn't get it at first, and then like clients, whatever, and then they'd be like, this is RoboCop backwards, and they'd be so excited. It was like and they would like, it's almost like we got like they kind of like associated some of that excitement and good feeling to us, even though we didn't really do anything. They just figured it out on their own. So it like helped us like get people excited for a consulting firm, even though it really wasn't anything.
Yeah. That's awesome. I mean, it did not stop at the Solar Cities. I mean, you had other, I mean, even Tesla was on your list as well. I'm just kind of looking through your client list. I mean, some big names on here too.
The mid 2000s was a great time to be. There's some really cool stuff happening in the Bay Area. Yeah, I feel really fortunate to like to be kind of be there at during that time. We got to work with, before Jewel was Jewel, they were they were called Plume. We actually knew them also at grad school. We graduated with them, and right afterwards, we're all kind of looking for like, they were looking for an office space for Plume, and we were looking for office space for Pokeball, and we found this awesome space in a part of the city called Dogpatch. So we actually ended up like we shared this office space with the Jewel guys for like a long time. And we got to like be tag along in their journey, but eventually we also got to when they switched from, initially Plume was butane based,
Mm.
and then when they switched over to lithium ion and like electric heater based, we actually got to help them prototype early packs, and Jewel prototypes was really it was really cool seeing when packs launched. Oh wow, like that's cool. Like we
Yeah,
helped
that's
with that,
some
and then Jewel
serious
launched.
serious volume at least.
Exactly, yeah.
Yeah.
And then Jewel launched, and obviously everyone knows that story. They just totally took off, and
I was gonna say, hopefully they paid their rent in stock options.
that if only.
Yeah. Right.
It was a really cool time. And then we got to, there are a lot of like technology centers in the Bay Area, like especially
Mhm.
like Bosch and Volkswagen and whatever. So
Yeah. So what do those mean? Like, is that like a showroom kind of thing, or is that like small groups of engineers kind of
it's
attached
basically like
to?
big. It seems to be, especially for like German, like Adidas. I don't think they're in Portland actually, but like a lot of like these like especially German car companies, they want to have access to, I think, Silicon Valley talent
Hmm.
probably, and like just like have like a footprint because there's so much innovation going on there.
Hmm.
And so they open up basically they're research centers where it's like stuff going on there probably won't see its way into a car for like a decade or more. They basically like are doing like some very like skunk works probably stuff. I remember I interned at Bosch, and the stuff I was working at, if it was going to be in a car, it would be like, this was back in 2005. Maybe just now it might be seeing its way into like actual production.
Oh wow.
So they
Okay.
just have these technology centers where they're kind of like working with PhDs from Berkeley and Stanford, and like engineers from the area to kind of say what if type technology, right? So we got to
Mm.
work with Volkswagen. Tesla early days, like it was a small thing. It was just like, I think it was like we helped them, like they needed to test batteries and they wanted to, like, how do we test batteries more easily? So going back to testing again, right? It's always, everyone's got the same
Yeah, yeah,
problem.
yeah, yeah.
So we helped them, just, it was like a really simple circuit board to just, make battery testing slightly easier.
Did you start to like build your kind of the Pokeball brand based on testing specifically, or was it more kind of general purpose?
No, we actually wanted to do like product development.
Hmm.
We actually did. It's funny. A lot of our work was around. Looking back now, I didn't really put that together just now. But even for Volkswagen, we did. Remember? Are you familiar with Junior, Stanford's like self-driving car?
No, I don't think so.
So Volkswagen and Stanford, collaborated together on, back, remember the Urban Challenge? I think maybe it's still going on, but it was like the whole idea, like, who
Oh,
can,
the DARPA thing.
yeah, who can first navigate an urban setting without
Hmm.
completely autonomously. So we didn't actually work on the junior stuff, but Volkswagen was very much into like instrumenting out their cars and seeing, like, where is power actually being used, and where can we optimize? Because at the same time, like, people are also very much, and still are, we're concerned about like miles per gallon and all that kind of stuff. So we had like a big project.
Oh, Volkswagen was interested in miles per gallon, huh?
Yeah.
Sorry, I'm never gonna let that one go.
No, yeah, they earned it. Yeah, they get
Yeah, they did. Yeah,
they,
yeah,
they dug their own grave there. Yeah,
yeah.
but yeah, we had a big project with them where we basically helped them. There's obviously like the powertrain, which is going to
Sure,
consume
sure.
the most, but all the different, especially as more and more things run off electrical system, they start becoming meaningful in terms of like, well, how much power does your sound system take up, or how much
Yeah,
power does
right.
this system or that system.
Hmm.
And there wasn't at the time a really, it's funny enough, the car itself couldn't tell you, hey, this is the breakdown. They actually had to go in and we built out like a lab view setup. It was this big old thing.
Oh,
But
cool.
yeah, I guess a lot of the projects were like more on the like help us like build a test rigs type stuff. But we did, like so we kind of split, like, Solar City, Jewel, that kind of stuff was like, product facing, but there was a lot of non-product facing stuff as well.
Yeah. I mean, well, I think about it like especially when you work with big companies too. Like, there's so many subsystems, interrelated stuff. I think about the clients I have these days are a lot of smaller clients, and like, oh yeah, I like them because I get to do more of the thing, but it's usually the output is smaller, right? It's a
Right.
smaller device, smaller whatever. But like when you're in a car, it's just subsystem on subsystem on subsystem,
Right. Yeah.
and it's just that is. I think about when like, oh, what do engineers do there anyways? It's like, well, they're making sure that their thing doesn't break the next thing down on the CAN bus or the LIN bus or whatever,
Right.
and
Yeah.
they just have to make sure, and then getting into production and then doing all these things. There has to be that level of reliability and testing anyway. So that actually makes a lot of sense, specifically in cars, but other people too. They need that same kind of reliability piece.
Yeah. Absolutely. I agree. Yeah.
Yeah, I feel like it's just kind of a part and parcel of like putting real stuff out in the world, like like actually manufacturing things. It's like no one's going to be happy with a 50% yield, or a thing that needs a firmware update every 2 days because it's like, oh, whoops, forgot to test that.
Right,
But
exactly. And especially, and in the firmware world, it's like it's not even as easy as, sometimes it's like a firmware update and the resistor value is wrong. So it's,
yeah, right, right, right,
everything is
right.
like so tied together in hardware and like in embedded systems.
Yeah. So I mean, so yeah, lots of cool. I mean, we'll link all these in. You have some case studies on your site; those are great to read too. So, what kind of made you stop doing Pokeball?
I think there was always a little, seeing the Jewel guys. It's like there's something cool about like seeing something all the way and like being,
Hmm.
like with Pokeball, it was really cool because you get to see lots of things and get to work on a lot. I learned a lot just because I'm like, like one day I'm like writing, a CAN driver, like, or the next day I'm working on Zigbee, and one day I'm working on LED, like, like
Hmm.
you get like all over the place. So like you
Yeah,
very
it's a
quickly have to
smorgasbord of
learn.
electronics fun stuff.
Exactly. But you never get to like, see it to completion, right? Like Solar City went on to do great things, and the Plume guys, and then like they went on to go really do great things. So it's like you kind of like miss out on that.
Hmm.
We actually tried to tackle that, like kind of like, oh, FOMO of, product FOMO, where we actually started our own. We spun out a company from Pokeball called Minna Life, which is actually also a really funny story. Well, I
Mm.
find it funny now looking back, but basically we were like, we really want to, like, we feel like now we know a lot about, like mechatronics and embedded systems, and we feel like we can make a pretty cool product. What space should we tackle? Like where is the most need? Back then also, especially in Stanford, the big thing was need finding, like find the need.
Mm.
So we were like, where's the need? And a friend of one of the people at Pokeball, was like, hey, like I know someone in the sex toy industry, not the sex industry, sex toy industry, and she's always complaining about how bad the quality is, how bad the like it's just these toys are just total garbage. So it's like maybe there's and we'd never like we're just for engineers. So we kind of like, okay, that's interesting, a little bit outside of what we were thinking, but it needs a need.
Sure.
So we started doing some, we actually like we did like let's interview some people and like and look at the industry and look at get some buy some stuff and like take it apart and do the whole like the whole thing. And we found out like, hey, you're right, like this industry is like it's it's basically built on people being too like because of stigma. They're never going to send these things back, they're never going to complain.
Ah, yeah, yeah, yeah. And it didn't seem like, I mean, like prior to like, yeah, like I don't know what the product was called, but it was like, yeah, there is a lot of like low quality stuff that was out there. And then I remember there was a Bluetooth vibrator that came out like maybe 10 years ago or so. And like, I remember then starting to see other companies that were like in accelerators and things like that as like, more people trying to get into that industry as well.
I think everyone like it's like how in Hollywood like there'll be like an asteroid movie and then there's three asteroid movies and
Yeah. Right. Yep. Yep.
whatever the like the thing is that's in the air, like everyone kind of catches it and it just kind
Yeah.
of happens. I think something similar was happening. There was Jimmy Jane, and then we were obviously doing something. And I think different companies are trying to like approach like some companies like the branding in this space is really off-putting, right? Like we have to
Yeah.
fix the
Right. Right.
branding. And we were going, we wanted obviously to have really nice branding. That was definitely important to us. But I think our take was because no one's going to return it or post to social media about how shoddy the product, that manufacturers of these toys were like, let's just make it, let's cut as much cost as we possibly can
Mm,
so that we can make our margins. And and because people are they're kind of like everything was about cutting costs and getting costs down and not thinking about like, is the material medical grade, is it safe, is the
safe.
UI
Right.
intuitive, like is it actually fun to use, all that kind of stuff. And things like these toys would typically break like in a month or two or whatever, and then they just go buy a new one or whatever. So we were like, we're going to fix the product, like we'll have good branding, but our play was going to be we like did a lot of prototyping. And again, this is where testing was very hard. This is a classic case of would be awesome if we get some, like how do you test a vibrator and get meaningful data without questionnaires, right?
Yeah. Right. It's very subjective instead of objective. Right.
Yeah, we really didn't have a good solution for that. But we came up with this. A lot of these toys that really are just like intuitive buttons to like make it go faster or slower, like different vibration patterns, whatever. And we thought, wouldn't it be cooler if the whole interface was just like a really cool thing that you squeeze it, and the harder you squeeze, the harder it vibrates. That was like our whole thing. It's like
Mm.
we're gonna build this, build out this technology and all that kind of stuff. So we actually, we got some good feedback. We actually went, there's a like a, I wouldn't call it, I don't think CES would call it a sister show, but there's like at the same time as CES in Vegas every year, there's a, they call the AVN, which is
Hmm.
like the show for this industry. And we actually went and set up a booth, and, people seem to like, they'd, like test, like we'd show it to them and they're like, oh, this is really cool. Like I could see, these are mostly wholesalers, right? Or retailers. And so like, I could see ourselves carrying this. So we spun out the company, even though, we weren't planning on like leaving Pokeball yet. We're like, okay, we're going to like spin it out and run it, but it's going to be again, a side, kind of how Pokeball was a side project to smart homes and became our full thing. We thought we would run Minna as like a side project and eventually maybe we'd go into it. But one thing we learned very easily is that the same thing that kept people from like, returning it, the stigma around, also kept us from marketing it. So
Yeah.
I think we made like a really nice product, but we never could quite get it to take off when we were running it, just because we couldn't solve the marketing part. Like no one, you think at that time also people like, things were really exploding on, so like Facebook ads and Instagram,
Mm.
and, we couldn't take Twitter. We can take advantage of any of those things because none of those platforms, they all had like morality clauses around like what you could do. And we don't, we didn't agree with them. We think that's, that's unfortunate, but it meant that we never figured out how to, and I think it's also, it was like, I think I think now it's changing, like, 10 years later, I think now it's still, companies are still hitting their head against that, but
Hmm.
it's, you're finally seeing it shift towards, okay, like this is not this thing that should be kept in the dark. Like
Yeah.
we should be able to talk about this. You should be able to like have a Subway ad. There's lots of, there's companies fighting the good fight and trying to like, hey, like this is a normal product. Like, why can't we,
Yeah.
talk about this? And so,
I would just imagine like a lifestyle product too would have outsized marketing need in the first place. Just like you would
Exactly.
really need to have you need to not only get over the stigma, you also need to like just really spread the word a lot, and that's just a tough thing to do, I would imagine. So
And we
yeah,
also, like one way people before us got around like not like, let's just make it cheap enough so it's an easy buy, right? If it's
yeah,
$20
exactly.
and it
Right,
doesn't work,
right,
whatever. But because we wanted to do it right and use good materials and actually have good design and have like technology that's intuitive, it was it was a premium price point. So now you're at a premium price point, and it's like, and no one's talking about us, right? It's like
right. And you can't talk about how the value proposition. Yeah, exactly. That's a really
exactly,
tough
and
tough
and
thing.
like you can get reviews and stuff, but the best review is a friend saying, "Hey, like this is awesome," and we're just not going to get that.
Right.
Anyway, so it's actually still a company. Like there's still, we still sell products, and
Oh, cool.
we actually kind of shifted from that to more like therapy, like Kegels and stuff like that. So we did kind of shift more to sexual health away from more of the pleasure side of things,
Hmm.
and that's still going. But it never it didn't like it wasn't that like hockey stick growth that we needed to kind of like stop
Right. Raise
consulting.
funding and all the other stuff. Right.
So we still, we're still trucking along. And I think eventually, and then so eventually I was like, I want to move. My family was in New Jersey. So I always had the itch to move to New York. And I kind of had the feeling, that maybe New York's about to like, ride that hardware wave. The Bay Area obviously has it and it always will have it, but it's, like Silicon Alley, right? Like everyone's talking about how New York's gonna become this
Yeah.
new,
Right.
this new
Yeah.
hub.
Well, they have to put silicon in front of something, and so yeah. I mean.
Exactly. So I always wanted to live there, and my family's there. And then, like, it seemed like a lot of tech was starting to happen. So I thought,
Yeah.
keep Pokeball running, but maybe we'll just have like an office in New York. And one of our very first clients was a startup called Ringly. This is like we were doing product development, like helping them design their first rings and write the firmware and design the board and all that kind of stuff.
And Ringly was the one that had like notifications on like a ring. Is that right?
Exactly. Yeah. It was like, like
Yeah.
at the time, like if you wanted like to be notified, it was either your phone or like
Right.
something that looked
This
like a sports
pre
band, right?
right pre smartwatch pre. I mean, I guess was the
Pebble was out, and you
Pebble
would
was
like
out. That's it. That's
Fitbit
right.
was, but it was like and talking to Christina, the founder, I was like, she's like, yeah, like if I want to go on a date or I want to go out to dinner, I don't
Hmm.
want to wear a Fitbit. Like I still, but I don't want my
Right.
phone on the table because that's also like there's like etiquette around that. But I still would like to know, there isn't an option for like
Right.
being notified without
Subtle notification.
exactly. So she was designing really beautiful jewelry that had this technology, and it was a really it was a huge challenge actually because imagine
Yeah.
getting
Oh, this form factor is crazy. Yeah. I
the
mean,
form
just a
factor is crazy, and then
battery
it's
alone
metal, right?
is
It's
yeah.
like
Right.
most of the things are like plastic or rubber or silicon, and now you're putting a Bluetooth radio in a metal piece of jewelry. It was I mean it was an awesomely fun engineering challenge, but it was a whole thing. But anyway, so initially we were working via Pokeball for about I think six or 12 months, and then they had a really successful pre-order, and so they also like were able to raise a Series A from Andreessen Horowitz, and she really hard sell me. It's like, hey, like this is a really cool space. I think there's a lot here, and I was loving the work. So I basically so basically what happened is Pokeboard kind of like two of us were like there's four of us. Two of us were like trying to make Minna really work. So they were spending most of the time on Minna, and then there's two of us still like running Pokeboard day to day. Christina kind of like said, hey, like you should join us. This is gonna be really cool. I don't want to leave my other partner like out hanging. So I was like, hey, like this could be really cool. Like I basically like gave him a telephone. I then gave him the pitch. Like, hey, like we've been doing Pokeball for 8 years now. Maybe it's time to just try going all in on a startup. We both decided, yeah, the timing's right. Like like we didn't necessarily we weren't super excited about growing a consulting business because
Right. Right. Like growing requires it to become a different animal. Like you become a manager of other people doing the fun stuff.
exactly. So I was like, do we want to be almost just like a biz dev manager of a consulting company, or do you want to? Is it like just the two of us, and we can be very happy doing it? Probably have more like a lot of flexibility and how we work and who we choose to work with, or we can kind of like jump in and kind of like see what it's like to actually go all in on a startup.
Yeah.
So we did,
That's
and
cool.
that was kind of like when Pokeball we said, okay, like we're going to close up shop, and so the other two guys, like I said, the four of us, two of them went and said, okay, we're going to go all in on Minna and try to make that work, and then we left and went to Ringley.
Did you have to put a blog post up about how you were whatever the
We didn't. No, we
backwards
didn't.
of powering down is like power down and like reverse because it's like
Luckily, we
RoboCop.
didn't have to. At the time, one of our at the time our two biggest clients were I think Adidas and Ringley, and one of them knew
Mm.
why we were leaving, and
Right.
I
Right.
think
Exactly. Yeah.
Adidas was okay. They didn't need to apply.
Yeah. That's good. That's good. Well, that's cool. What happened? What ended up happening with Ringling? I remember hearing about it, but I don't know what the ultimate Did it got out and to market and everything?
Yeah, we definitely got to market, and I think there were a lot of not a lot of definitely not a lot of parallels with Minna, but one thing about Minna, I'm gonna jump back to Minna, was like people who did get it, there were some really passionate users. So we always we're
Sure.
always like,
Yeah.
God, if we can just figure out like the sales part of it, like people who got it love it, and
Yeah.
if 10 people love it, there's probably 10,000 more people who also love it, and we just need to figure out how to reach those people, and then we have a
Right.
company.
Is it like the problem of like, I forget the product cycle, but like there's always like the first adopters, like the bleeding edge first adopters.
Mhm.
Is it like that kind of thing where then you had to find the next group of like the slower
Exactly,
adopters, whatever they're called?
and because with Minna, it was like the problem was just we didn't know way, there's no way to find them. We just I mean, there is a way, and it's there's definitely ways to do it, and we maybe like via
Yeah.
make more content. We could have made more content or whatever. I don't know exactly what the right mix of things were, but with Ringly, it was the same thing where like I after Ringly kind of turned off the lights, I had people be like, hey, like the app's not updating anymore. Can I get like the code base? Like I love my Ringly.
Wow.
Like I
Yeah.
want to still be, I want to be able to still like have my app, or what happened is like the iOS would update, right? So the app wouldn't work anymore. So they wanted to
Oh
like
yeah.
recompile the app for the newest iOS. Like that's how passionate they were about the product, which is really, it was like, oh, like that's awesome. I'm glad I worked on that. But it's kind of a bummer that like, but again, it was the same thing where I think we just never figured out the sales. Like, is it a product that you do through Amazon? But it's a fairly, we were trying to do high end, not like super high end, like
Yeah.
$50,000 piece of the ring, but it was
Yeah,
still
it's like
like
the marketplace of like Apple Watch is it's a as much a fashion statement as it is a device.
exactly. We're using precious stones, and we're doing like gold plate. Like we're doing everything you would do for a real piece of jewelry. So like, where do you sell that? But the problem is we were a consumer device. So it's like we needed volume. So we needed the Best Buys and the Amazons of the world. But our branding was fine jewelry, which
Yeah, direct to consumer kind of thing.
exactly,
Yeah.
which is not Amazon. It's not right. It's like
No.
you don't
Right.
go to Amazon to find, I mean, maybe I actually don't know. Maybe you do now on Amazon. I actually have no idea. But our branding was very nice. It was amazing branding. Christine did such a good job, and it's just like, so we kind of knew that direct to consumer was the play, because that's how we people would show up and be like, oh, I want this, right? You needed it to make it aspirational or whatever. So I think we just never got the volumes, even though people who got it were really passionate about it. But I think we also, like I said, on a manufacturing and design side, it was, I think our runway was shorter than it needed to be, because it was such a challenging design. And what I mean by that is like rings are small, so we're trying to get all
Sure.
this functionality. We basically were finding the world's smallest of everything, like the world's
Yeah.
smallest
Yeah.
battery, the world's smallest motor, the world's smallest like Bluetooth chip at the time. Everything was the world's smallest. And like if you're Apple, that's awesome, because you can prototype like crazy. You can throw everything you've got at it. But when you're a small startup, you don't have that ability to like do like a bunch of different antenna designs, and like try out of different things. And like a lot of these, like the world's smallest stuff, you're like, cool, can you order 50,000 of these things? And we're like,
That's
no,
right. Yeah.
we can order 3,000. And it's like,
Right.
well, we're the world's smallest, so we're gonna go talk to like who can order 50,000. Like because everyone like they're in the world of like, well, since we're the smallest, like other people want us, and we're gonna be really hard to negotiate with. So like we had just had a lot of I think issues around getting manufacturing properly up and running. And our supply chain was crazy, right? Because you had fashion and consumer electronics kind of like
Yeah.
smushed together, and they're the two, like every industry's got their supply chain, right? And consumer electronics is a very established, you probably know it very well, factory CMs that
Yeah.
do.
Every day I feel like I know it less and less, but yeah.
It's true, yeah. And like CMs who do electronics, they know where to get the resistors and the ICs and the motors. Like they know their thing. And fashion brands, fashion factories know, they know where to get the leather and the stones and whatever. But how do you like bring those two together? Because they have different, they operate differently. Like electronics yearly cycles, right? Like typically around
Yeah. Yeah.
early fall you launch, you have once a year cycles. Fashion is quarterly, right? Every season is a new electronics, like, oh, we've got 2 SKUs, 3 maybe, for really being ambitious, right?
Right.
Fashion's like, hey, we've got 20 SKUs, because if you don't have 20 SKUs, you're going to get lost in the, it's like trying to like figure out how do we, so like the fashion side of things, they wanted much bigger orders. They wanted a lot more, like they just wanted, they expected different, and we were like, no, we're going to do 10 SKUs this year. And they're like, what? All year you're going to do 10 SKUs? And
Yeah.
the electronics side, they're like, you're going to do 10 SKUs? Are you crazy? This is a new product. You want us to launch with 10? That's
Yeah.
you can't do that. And it's like, Like how do we so just fighting that battle, and it was a whole
Yeah.
thing, and
Oh
so
my god. Yeah. That's I mean, this is not like a low price thing either, right? It's like
right.
I mean, the site's still up. It says 165 for a ring. I mean, like that's I don't
Yeah,
know
and then
how
when there
much
was
that went to electronics, but fashion has the benefit of like what are you paying for there? But like
right.
I don't know how much that actually played into your bomb costs and everything.
I mean, it was our bomb cost was always higher than like I think we thought it was going to be because of all the like like our board our
Yeah.
board was a
Yeah.
basically we called it the burrito because it was a flex board because the only way we could get it to
Oh wow.
we basically made a piece of origami, so we'd populate this board, and then I feel bad for like we were training these people at the factory to like fold it in the right order, and then like
Right.
basically
Right.
like with a soldering iron, like you're not well TIG whatever the thing where you like kind of like spot weld it, but it's with the
Yeah.
solder so that it like stays in burrito form, and then like put it was I mean it was
Wow.
crazy what we were trying to do. It was crazy. Yeah.
Mm. Well, that is. I mean, like that's a lot of really good experience. But I mean, like you said, I mean that is the thread throughout all of it is this testing. So let's get over to logger data again and talk about how are you fixing this, right? So what is different now in 2021? You know, you are helping other people now to do their testing better.
Right.
So I don't know if it helps to like have an example product that we could talk about. You know, like a dummy product doesn't have to be anything real, but like
Yeah, we can use Ringly. Like I think kind of
sure,
how I got to Logger was like it's
okay,
basically after Ringly left, I was like a little burnt out. I spent a lot of time in China, and then it was just like just it was like any startup that doesn't quite make it. Those last the last few bit is always like, I mean I didn't even say until the end. Like I left a little earlier, but like just living in China trying to get those like
yeah,
shipments out the door was a lot. So I kind of like took a step back, and I wanted to be like, well, what's my next move? And I remember thinking, it's like, God, I wish I had better testing tools when I was at Ringley. Maybe I should
yeah,
get into, and I always thought B2B would be a fun place to B2C, like Minna and then Ringley. I was like, consumers, there's like a psychology aspect to it, right? Like there's a marketing
hmm
branding that you have to kind of like, convince them that this is something special. And there's a whole part of it. Whereas, B2B, you can kind of get away with like, hey, this is going to save you money, or this is going to
right,
save you
yep.
time. It's like an easier, the marketing is,
Yeah,
there's
it's
still
just
challenges
pure
around it,
value
but
based instead of like perceived value, right?
exactly. So I was like, like I think B2B could be an interesting play, and I want to get into like better tooling. Maybe there's something there. And I didn't immediately come up with like what Logger is now, but I was like that was like kind of like the genesis for why I wanted to get into this to back into like embedded tooling and that kind of stuff. So I remember the one thing really stuck out to me at Ringley was we actually introduced step tracking into the ring, which is a huge challenge, right? Because
Yeah,
like
yeah, right.
it's one thing to wear on your wrist. Like, when you walk, your wrist doesn't like do a bunch of things, but your fingers are constantly moving, right? Like you might be sitting, like tapping your finger. And so like, how do you properly track steps when the device
Right,
you're using
right.
to track the steps is on a finger? People do, everything with their finger, right? So
I mean, is this like I could like go and like type up a bunch of code and then I could be to my wife, I could be like, oh yeah, no, I ate like 3 donuts today, but it's not a big deal. I walk like
you could
5,000,
have, yeah, you could have,
50,000 steps, you know?
yeah, exactly. Like, are you like, no, I didn't play any Nintendo today. It's like, well, I'm looking at the Ringley app. It looks like you played some Nintendo today. So we had to do a lot of testing around like so we had the IMU and everything, and like getting the data out, like go walk around the block, go jump up and down, go type on the keyboard, like, and then like how do we
Yeah,
get that raw data out, run it through MATLAB, like do a bunch of process, like we have to figure out basically what's the algorithm so that we can properly filter properly, like we to kind of get what we needed. And every time we wanted to get real-time data or data, like we would be, and like again, like this is from a tiny ring that's metal encased, so we're like drilling tiny
yeah.
holes trying to get like UART wires
Oh
out the
boy.
thing to like a FTDI, like USB module that's like then into someone's laptop who's like walking behind. It's like it's a whole thing just to get like data so that you could actually do the real work of like of number crunching it. And so it was like so my first time was like getting data is really 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 hard. And then the other thing that happened a lot of Ringley is we'd have a new feature, and on the firmware side we didn't really have a good way of like, did we break something? Right, like we were pushing new
Right,
code.
yeah,
Do we
right.
do we is there a regression in here? We had no automation at all, and no like no regression testing other than like, yeah, it's really scary, maybe we broke something. And sometimes we did. Sometimes we'd break like DFU in it, like we the image would be slightly bigger, and we'd something would change
Yeah,
in the image layout, and DFU would break. right? And which would be
Were you doing over the air updates as well for everything?
yeah, exactly,
Yeah,
yeah.
yeah. So that then basically effectively bricks it until you then go and drill into it or open it back up, right?
Yeah.
Yeah.
And this
Wow.
is jewelry, so it's not like, well, send it back and we'll reuse it for the next. It's like, nope, this whole thing is,
Yeah.
is just done. So, we do lots of manual testing and just like kind of like, slamming the device every time we push a new feature or whatever, just to make sure we didn't like break something that we couldn't, but DFU was the biggest one that we worried about, right? Because then you
Right.
can
And for
break that
people
and you
that don't know, that's device firmware update. That's the
right. Yeah.
basically, yeah,
Yeah.
couldn't update the firmware after that as effective bricking, right?
Yeah.
Yeah.
But sometimes I remember one change we made and like we were parsing, so what we were using an Apple protocol for the Apple for device that were connected to Apple. There's a protocol, ANCS, that you can use to kind of like make like rings that can talk to your phone. And we were like, we're writing the parser in C, right? So there's probably a million ways that we're doing it wrong, but we changed the parsing just enough so that all of a sudden like notifications weren't coming in, right? And it was the
Mm.
change we made didn't even like affect that part of it, but we broke it. So luckily we caught it, via testing and all that kind of stuff. But I remember like on the website of things, you just you can deploy a website without even touching it because of CI/CD, right? Like you just write your test as long as everything passes in your
Mm.
test automation, you can like it can go live and no one has to do anything. And in firmware, it's like you spend 3 weeks just like trying to hit it as much as you can because you're so
That's right.
scared
Yeah.
that you're gonna break it.
Right. And like one misstep in one part of that multi-step process, and you could break that chain of like the whole. Especially if you like were you building up like the bootloader as well, and like was it like a Nordic chipset or something like
Yeah,
that?
we had like 3 images on it, right? The bootloader image. There's like
Yeah.
so many moving parts here. There's no automation.
Oh, people that don't know CI/CD, that's can you explain that acronym as well?
Yeah, so I'm actually like as a firmware person or embedded system, it's I'm new to the idea of CI/CD, but it's continuous integration, continuous deployment. So the idea is embedded. Like my experience from firmware is that you merge to master. But the idea is you would merge new code to master infrequently because you're so scared you're going to break something. You like want to do like a lot of
Right.
manual testing,
Right.
and then you finally okay, everyone agree this is going to work.
Right. This is version
Yeah, exactly.
4.2.6.
So it's very slow integration, whereas continuous integration is like, hey, everything, when you push, things get built automatically. But the real magic is now we also are going to run a bunch of tests that you've written so that, you push something to GitHub, a branch, whatever, a bunch of, it builds your project. It runs all the tests that are, all the tests, tests that were written months ago. It runs all of them to make sure nothing
Mhm.
broke because of the new code you wrote. So that's like the CI part of it, and then the advantage of that is you just get to integrate much more quickly. You're never scared to like push new code, and because if you break
Right.
something, the idea is that you're going to catch it and you can fix it immediately. And then CD is this is probably less relevant in firmware. For websites, you can also then deploy it immediately, right? So everything passed, green check mark, go live with the site, go to production.
Yeah, that's crazy. So then how do you actually do that? I mean, so is this now with Logger Data doing this kind of integration and deployment and stuff, is it independent of like the tools that you're using? Do you have to use command line tools in order to implement this sort of thing? I just think about some of my tool chains that are somewhat IDE dependent, but maybe that's just my perception as well.
One thing about the embedded world, there are actually a lot of amazing tools, right? Like we've got really really nice tools for lots of different things. It's just that because of it's such an old industry, like right dating back to I don't know 70s, 80s, right? Like it's
Yeah.
Apollo
Yeah, the
11. It's
beginning of the computers, right? I mean,
yeah,
like, yeah,
exactly. It's such an old
yeah,
industry that like things kind of like are in their lane and they don't think about like, oh, now we now have this concept of CI. Like, it's like, well, we've been doing this way for 20 years. We don't work with that concept. It's like, and we're not going to change or something
right,
like that.
right.
Whereas in the, like with web stuff, it's like, it's so new that, they're able to like kind of come at it, I think, a little more fresh than in our world.
Right. I feel like when you suggest a change, you don't get like nodding of heads. You get old grizzled people being like, yeah, but back in my day, we coded by hand."
Exactly. Or JLink already does that. Why do we need it's like this
Right.
all
Yeah.
already exists. I can just buy
Yeah.
a
Yeah.
Raspberry Pi and I can do it's like and I think one thing we try is like yes, we definitely agree that you can do this. You can
Yeah.
go
Right.
you cobble everything together. What we're trying to do is build something that's so robust, really robust and easy to use so that you don't have to buy the Raspberry Pi and learn how to like, write a bunch of scripting and all this kind of stuff. So no,
Right. Well, and
you
even
can
that is
use
just
your
a perceived robustness too, right? I mean, like one script is, Python updates or something like that, and it's like, oh yeah, okay, well that doesn't work anymore.
exactly, yeah,
Or like that engineer who wrote it leaves, and like that's the biggest thing I feel like is like someone leaves, and then that person that was updating the script, and you didn't know that they were doing it, every other week they were checking in on something, and now it's like, oh yeah, that
right.
that hasn't worked for months.
They had one little trick that they never wrote down, and it's
That's right.
it's
Yeah,
like
exactly. Yeah.
so. And so the answer to your question is like we actually we made it a point to work with like part of our product. There's a physical gateway, and that's kind of how you like actually physically connect to the hardware. And you can plug in a JLink, like it'll work. It's all
Hmm.
seamless. Like it doesn't, you don't need to, like we have a debug pro built into the hardware. But we
Hmm.
understand that people, like, well, like our whole setup is there's JLinks everywhere. Can I just plug your gateway into the JLinks that already exist everywhere? So it's like, yes, you can do that. And in terms of like
Right.
building,
Right.
like, say you're using like ST's cube ID or whatever, really that's
Hmm.
just built on top of ARM none GCC or whatever. And but
Hmm.
they have a command line, like Eclipse has a command line way of building that project. So we work with existing IDEs, but we give a lot of like tools, like wrapper, like we call them wrapper tools, so that you can still like use the logger command. It's all command line, the logger command line, to build your Eclipse project from the command line, to
Mm.
connect, from the command line, to like interact on your spy bus from the command line.
Ah, okay.
So
So let's walk through a project now. So okay, so we've got an STM32 part, and we're currently in tears because you can't buy them anywhere. But we'll ignore
yes.
that for now. Okay, so I'm writing code. I make a change in Eclipse. It's already hooked into Logger. What happens then? Like, so it's like run a hit compile.
So one thing we're pushing a lot is the idea of Dockerized build environments. There's another tool that comes from the web. Like we're taking a lot from the web. That's
Sure, sure, yeah.
one thing you notice. Like, well, it's like, hey, what's the web doing? What are they doing right, at least? And like how can embedded systems benefit from that? So one thing we found was that a lot of people complain about their build environments because things is also very fragile, right? Like your build script relies on Python 3.6 running, and then
Hmm.
you accidentally install 3.9 and something broke, and now you have no idea what broke because you didn't write the build script or whatever. Or like a new team member comes, and everyone on your team is on a version of Mac OS that is older, and they're about a new computer and the new Mac OS. It's like
Yeah, right.
build environments are notoriously fickle when it comes to like being like always working. But if you put your build environment inside of a Docker container, you basically get to like freeze it into. It's like, okay, we Python 3.8, ARM, ARM none GCC 9.2 and whatever, like
Hmm.
this is what the build environment is, and that build environment lives with the GitHub repo. So
That's
if
right.
a new engineer comes, they can clone it and they can immediately build it because it's the build environment's in the repo. It doesn't matter if they're Windows, Linux, or Mac, and or what OS version. So we're really pushing the idea of like, hey, move your environment into a Docker container, which also has huge benefits when you start talking about build automation. Going back to your example, so you're in Eclipse. We also host a bunch of these Docker images. So we have one for SD Cube.
Okay, cool.
So you make
Yeah.
a change
So out of the box, it's easier. That's what you're saying.
out of the box, easier, right? So you don't have to build
Yeah.
your own Docker container. So we have one for SD Cube. So you say, okay, like I made a change. I would like to push this change. In theory, like if you're doing it the way that we advocate, which is write tests and so that you can catch regressions. You've also written tests for this change.
Hmm. Yep. Yep.
So first, what using the log, so you've got a piece of hardware somewhere, and you've got the logger gateway hooked up to that hardware, and that gateway gives you access to your hardware via JTAG, SWD, GPIO, analog, SPI, UART, I2C, Blue, like all the things you would normally want access to by
Yeah.
plugging into your your computer. You get it via the gateway via the command line. So everything's at your fingertips. So you're like, okay, first before I push this to GitHub, I want to run all my unit tests. So you would run like logger test run. There's a command called logger test run. It runs your unit tests that you've written. And we work with different frameworks. One that we've tested a lot with is one called Unity. There are other frameworks you could use that we would work with. So okay, cool. Like
Okay, so can you run just one example unit test that you might run if you were writing a new feature that you were trying to put on there?
okay, so maybe you've got like an IMU on your board, and you're trying to convert it to a quaternion, which is it's like a four coordinate thing that is used a lot in like I'm not actually a quaternion expert. So I'm trying to. But I just know that if you ever try to like
Like drones or something like that?
yeah, any kind of like positioning, you're probably going to come across quaternions at some point. Which I am like
Okay.
you take like AX, AY, AZ, GY, GX, GY, GZ, and there's some magic that someone else has figured out that you run and it turns it into a quaternion, which then tells you exactly like the orientation of your drone or your remote
Ah,
controller or whatever it
got
is.
it. Yep, yep. Okay.
So you've got some function that says like convert IMU to quaternion, right? And like you want to make sure that that function does what you want. So you write a bunch of test cases. Like, what if I give it this data? What if I give it invalid data? Do I catch that? What if I give it
Mm-hmm.
what about valid data, but that's corner cases, right? Like all zeros or all FFs or whatever. So you kind of like write all these tests around like to kind of like make sure like, okay, this function works. And then so those like each like type of test would be called like a unit, right? A unit. You're testing a
Mm-hmm.
unit
Yep.
of that function. So maybe you're giving it a specific type of invalid data. This unit test is like invalid data that is 8 bits, even though it should be like 4 bits. Or I totally made up the example.
Okay, sure.
And then once all that passes, you're like, okay, like I think I've got good test coverage on my function because they're all passing. And then that the win with that is then if someone down the road either modifies your quaternion IMU to quaternion function, or maybe they like that function calls some other function that they do modify. If
Ah, yeah.
something breaks, it gets caught because of all the tests you wrote, right? So
Got it. Okay, so this is still on the code side though. So this is not like a physical test. This is not like some interface that's going to it. This is still the code interfacing to this test framework called Unity, and then doing these code-based regressions.
yeah, this is only code base. But one thing in the embedded world is I think a lot of people. So unit tests, typically people will say like you should do this. Don't do it on your target. Don't do on target unit testing. Do it on your computer. And
Mm-hmm.
I think there's some. I don't agree with that statement 100%. I think a lot of people who are avid unit testers would say that's what you should do. But I think a lot of the reason why you don't want to do it is because mostly it's really hard to do. It used to be really hard to run unit tests on your target because again there's a lot of like DevOps required to like actually get those unit
Yeah.
tests running on
Right.
your thing to run the code, and how do you get the output back to a command line? Whereas if you're just running on your host machine, there's like that's it. It's just running on your host machine.
Right.
There's nothing to worry
Lots
about.
and lots of horsepower and capabilities. Yeah.
Exactly, and it just goes right to standard out, and boom, your test passed or failed. But it starts getting a little, I think, a little challenging when what if your host machine is running an x86 compiler and you're running like a
Yeah.
16-bit compiler, or cross compilers notoriously have like like features that are not like standard, right? So like you can't really capture that. And what if your code actually pulls in what if your IMU to quaternion like needs to talk to something on hardware, right? Like everyone wants to
Yeah,
do
that's
like
that's usually where I get kind of caught up thinking about these things.
exactly, and they always say like, well, you should abstract it. Everything should be but sometimes you're like, I can't, like it's
Yeah, it's like a microphone. Like okay, so I guess I could play like a data stream that's been captured and maybe play that back, but then it's still like, is that really capturing everything about the microphone that might be happening with a microphone?
yeah, maybe in the ideal situation, you abstract everything away. So anything that's hardware is like in a hardware layer, and everything that's like just logic is can be like. But I think that's not the case. So we're also pushing for like on target unit testing. So this is one of the challenges with loggers. There's like so much that it does. It's sometimes I think it can be a little overwhelming. So we try to like bite things off in
Yeah.
like
Yeah,
very
yeah, yeah.
specific use cases. But in this specific case, you make a change. Say you are doing on target unit testing because you want to like part of your unit test have to pull in something on that's specific to your PCB. Maybe there's a spy temperature sensor that you need. It's like instead of like mocking the whole thing out, you just like I just want to read the temperature sensor. and
Right, right. Does it read? Yes or
yeah, it
no?
doesn't
Is
read
it
exactly.
is it less than like 140?
Exactly. So everything passes. Okay, cool. I want to, and so logger, you run logger test run, and there's some things, and what that does is, so even though you're on your computer on your couch, what it's doing is
Yes.
it's compiling your tests, it's flashing your device via the gateway, it's then running the test on your board, it's then taking the outputs of your test via UART, sending it back to your computer into the on the command via command line, and saying, hey, here's your results. And so everything
Mm,
looks like as if you would just run it on your natively on your computer, but a lot more
hmm.
happened, right? Like you did a bunch of other things. You compiled, you flashed, you captured data, you redisplayed it back to the command line.
Hmm.
So that's like, or maybe something broke, right? So say, okay, oh, one of my tests failed. I don't know exactly why. I'd like to open GD. I'd like to like set some breakpoints and walk through my code.
Mm.
Again, you can do that. You can just do logger GDB server, which opens a GDB server to your actual hardware, and then you can use your client of choice. Whether it maybe you want to use Sublime, or maybe you want to use Eclipse, or maybe you want to use VS Code, or as long as they support GDB, you can use any of those IDEs. And just like you're used to, you go in, you set your breakpoints, you press play, okay, oh, this is an unsigned int, it should be assigned, like whatever the thing is
Right.
that
Right.
like
Right.
you need to figure out. And again, this is all happening from you haven't left your couch yet. You're doing all this, and this is it's all just magically
Living the
happening.
dream.
Yeah,
Living the dream.
exactly. So now you made the change. A test failed. You found the bug via GDB. You fixed the bug. You ran the test again. The test passed. Now you want to go ahead and you push it, right? So we also work really closely with third-party build servers, like GitHub Actions, Bitbucket
Okay.
pipelines, Drone.io. And so like I won't go into exactly how they pull in the YAML. Imagine the YAML file living on your
Yeah.
in your project.
And YAML is like a script file that's used for like Dockerized containers, right?
Yeah, exactly. It's yeah.
This is all, I mean, so like some people like right now are listening, they're like nodding their heads, and other
Yeah.
people are like, Chris, who the hell did you bring on a hardware show? And that's the thing though. Like, I mean, like you've learned all this stuff, and it's like, I feel like it's just this thing where it's like, you just got to get into it slowly and really like follow the docs and follow the examples like you have, and then just like know that it's all going to work out. Like it's going to be fine, folks.
That's the crazy thing about embedded, right? It's like the thing where this ST project we're making, for all we know, it's like a smart toaster, right? It's like a very hardware based thing. But
Yeah.
you start thinking like, well, how do I make sure that like it's like I want to ship this? It's gonna connect to BLE to my
Right.
phone. Like it's gonna do all these
When do
things.
I make toast? How
Yeah,
do I tell if the
exactly.
toast has been toasted properly? Because I think that's the thing. Like a lot of embedded stuff, hardware and any hardware device, it's like I'm used to running the unit test. For me is I'm on my bench and I'm like, oh yeah, look, the LED lit up, and like, yeah, okay, cool. It like measures the thing that I wanted it to
Right.
measure. Like, and it's very subjective still, but that's just kind of that was the perceived only way to do it for a long time. It
Right.
feels
And
like.
not automated, right? Like it's like you
Yeah.
running and making sure like, oh, the temperature went to the right set point or whatever. So we work with like third party builder, and a lot of embedded teams we talk to basically like, yeah, we use GitHub Actions, and like, oh yeah, how do you use it? It's like, well, we just use it to compile, right? And it's like, well,
Mhm.
that's sure, that's a very valuable part of the way to that's one thing you should be doing is like you should be doing nightly builds. Hey, like it still compiles. But,
Mhm.
we all know that a compiled image is not necessarily one that's bug free, right? You still need to do something with it.
No, I have many on my computer that I could probably show as examples of like, no, there's some stuff lurking.
Yeah.
It's lurking in there.
Exactly. And they're like, yeah, but we don't do anything with the assets, the images that we create, because we don't have a good way of then taking,
Yeah.
so okay, sure, GitHub Actions made an image for me. Now what? Right? That's where
Now
most
what? Yeah.
people they get stuck. So it's like, okay, at least we're doing the build. So at least we know we're not breaking our build every night. But with
Mhm.
Logger, we hook in and it's like, okay, cool, you made your build. Now just do all the stuff you just did from your couch. Let GitHub do for you. Let GitHub flash your device, run the
Mm.
tests, all the do all the things you want. And if something fails, now you cut a regression, right? It's like, nope, here's a big red X mark. Hey,
Mm.
now we're actually getting closer to CI. We're doing continuous integration. Now you're not
Yeah.
as scared
Yeah.
to like, a lot of it, you have to like, your team has to kind of switch over to like a more test driven, TDD is
Yeah.
the thing that everyone talks about. You have to think as a test driven team, so that, part of the code review is like, well, where are the tests? It's not just, it's like, let me see your test that you wrote to make sure that you're writing the test and all that kind of stuff. But, that's the idea, is that now when you push your code, a lot of really cool stuff's happening, so that you can just keep moving forward. And you can have three
Mhm.
people writing code together and pushing, and you're not scared of breaking stuff, because you're writing tests and they're writing tests, and all these tests are getting run constantly via the gateway. And because we also do like analog and GPIO, it's like, it's not just unit tests. You can also do like system tests, right? It's like, okay,
Yeah.
maybe there's in this toaster, there's a really lightweight shell where if you send it, you can send a different commands over UART. You can like turn the heater on, and to a set point, or and you can hook that all up into our gateway, right? So maybe you've got a temperature sensor probe that hooks into one of our analog, or maybe it's an I2C temperature
Oh.
sensor. So you can hook all those into our gateway. So now when you're yes, you're writing unit tests, but you're also writing system tests that are also being
Mm.
automated, right? So now when you push your code, you run all your unit tests. Okay, cool. All the unit tests pass. Now let's run the system tests. okay, cool. When I send start heater command over UART,
Yeah,
it
yeah.
turns on the heater. I'm measuring that via analog. I'm, like capturing that, and maybe, like you can also. So one thing I'm getting really excited here, but like one thing you can also do that you can start automating is you can run Python scripts on our gateway, and I think a lot of embedded engineers by this point have dabbled in Python, basically for scripting. It's like, how do I automate this? How do I use Python to
Hmm.
like do a bunch of steps without me having to do it manually, right?
Yeah.
So there's a
Yeah, so that really closes the loop for me actually, because we talked obviously before the show and about this stuff, and I wasn't sure where the analog and all like the peripherals and stuff kind of fit in there, but that makes a lot more sense now thinking about having it. Okay, everything's done. You've loaded the firmware image that you built every night onto the device. Hopefully, someone's still in the office when it turns on the toaster heater element.
right,
but that idea of like, okay, now you're testing individual elements externally. It's not just like running the app that's maybe running on the device. It's you're specifically giving it like single output commands that
right,
then that's the feedback loop. That's the piece I wasn't sure about, because I was thinking like, oh, okay, if this is just running production level code, it's just kind of sitting there doing its thing. How would you stimulate it similar to how a user would, right? So like pushing down the lever is a hard thing, unless you start to move into the physical world, like past guest Jason Huggins, who does Tapster, right? Like a
right,
robotic finger
exactly.
type of thing. Like, I don't know how to do the physical world stuff, but having that UART there, you could at least do some of the input output testing like you're talking about.
So the physical stuff, I think at some point we're gonna have to figure out how to, at some point you just need to push a button, right? Like that's
Yeah.
that's
Yeah.
what you got to do. But a lot of times you can simulate what the button does, like via a shell, right? So you
Hmm.
still get a lot of that testing done without having to actually press the button. So
Yeah. 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 Exactly. I just hadn't put that. I hadn't closed that loop yet, and I think that really helped too. So that's interesting.
And I think like what a lot of teams are going to find once they start really thinking about testing and see, I was like, there's a lot of blog posts about why you should always include a shell in your embedded project, right? And people are like, okay,
Hmm.
I've never done that. Why would I do that? But once you bring the testing components, like, of course I should include a shell.
Yeah.
It unlocks so many other things, and a lightweight shell. You can find any number of examples online on how to like build a lightweight shell over UART, right?
Hmm.
So yeah, so like we're trying to pull all these different things in together so that people can really be like, hey, testing's really easy, and honestly, it's kind of fun. Like it's kind of cool doing. It's like it's cool that like GitHub just does this for me, right? Like not only and it could also like flash. Maybe you have custom like test firmware images that you want to flash as part of that test. So you could like
Yeah.
flash this thing like with 8 different things as part of a single like push. So there's a lot of cool things you can do once you start automating it.
It kind of feels like it's the same muscle that like what are those really complicated machines called?
Rube Goldberg.
Yeah, Rube
Yeah.
Goldberg machines. Like people like that kind of thing of like, oh, setting up all these different like interactions and stuff like that. But in this case, it actually like records it and it makes it
right.
possible to play it all back and like understand it better. So, but I feel like it's that same muscle that's the fun part. Like you're talking about, like how much else could we do by just pushing that first button to go?
Exactly.
You know?
Yeah. Yeah. Totally.
Yeah. That's great. That's great. I mean, one thing I keep thinking about with this sort of thing is like, I'm like you were with Pokeball, like a small consultant. I like so the overhead for getting this stuff set up always feels kind of daunting. So like, what is the getting started like? Is it tough to do? Is it something that a individual could get started by themselves, or is it more like, well, if you have a team of three, that's when it really starts to make sense?
So we want like teams of one to like we want to. I think teams definitely should be using in my opinion should be using Logger, but we want to get started with teams of one. And our whole thing is like if you think about like what Logger is doing, it's like, okay, someone could be like, okay, it's a Raspberry Pi and it's some AWS backend, and like you can start thinking
Hmm.
through what you need to build, and you can I could get there,
Sure.
I could
Yeah.
do it
Right.
myself.
Right.
But like how who knows how long that is, and like you hit one like roadblock, and all of a sudden it's a month before you're ready, or more, and typically it's a lot more.
Right, right, right. Well, and maintaining it over time too, right? Like, yeah, but like you said, Python updates, and then what? Like, are you gonna go change all your setup, right?
So our whole thing is you should be able to get set up with your first automation should happen within an hour of turning your gateway on. That's
Nice.
how easy it is. And we do offer a lot of we want to be very like hands on, because this is like, I think for a lot of embedded engineers, this is like the idea of continuous integration or whatever is slightly new, and GitHub Actions in fact is like a new thing, right? Like I think that's only
Yeah,
a
yeah.
year or two, or maybe a couple years old. So a lot of this stuff is just new in general. So we do
Is
have,
the GitHub Actions, is that like replacing like a Jenkins server?
exactly, yeah. It's, I would say
Okay.
it's like it's going against the Jenkins or whatever. It's like, hey, you can,
Okay.
you've already got GitHub. With GitHub Actions, you can do all this cool
Give us
build
more
stuff.
money.
Yeah, exactly.
There's one thing Microsoft doesn't have, it's more money.
Right.
Yeah, that's great. That's great. I mean, and I think the getting set up. I mean, so it's not cheap. I mean, pricing is still kind of up in the air, but it's not cheap. But when you start to think about selling this to a solo engineer, is it like the money's going to save me from a failed build? Is this like a save your own skin kind of thing?
It's definitely, it's like definitely like a bad release where it's like, there's a bug. I mean, there's always going to be
Yeah,
like, we
yeah.
can't, 100% no bug. We're not going to make that.
I guess how do I get my boss to pay for it? In this case, my boss is me. But like someone listening might be like, "Oh, well, yeah, how do I tell my boss that I should be doing this sort of thing?"
For me, for me, it's time. I know that I can find I will catch things quicker and more efficiently because of Logger, and that's time, right? So if I
Mm,
can save
yeah.
over the course of a year, 10% of time, that's I'll gladly pay for that. And so, like, like, I think, when I first started designing PCBs, I was using Eagle, and Eagle does
Hmm.
a lot of things really well. But as you get, a little bit more sophisticated and you start doing, more complicated boards, like, 4 layer flex or 8 layer, what you start, you start kind of like pushing what like Eagle does, and you start looking at things like, Altium and, kind of these higher end packages, which are
Back
significantly
yeah.
more money, right? And, we kind of went through the same flow in Pokeball, where at some point we're like, I'm spending a lot of time fighting Eagle, right? Rather than like, Eagle, like just working with what I need to do. Bomb management, like, Gerber generation. There's just things that you want to, like, we're doing some more sophisticated things that Eagle doesn't just do,
Mm,
and Altium does do. And we want it, so, it's like we start looking at the pricing, and then you buy it and you're like, oh, this, my time's like, it's doing the thing I want to do. I'm saving
yeah,
time.
yeah.
I can't go back. I definitely can't go back to Eagle now, because I'm not gonna relinquish those hours. Even though
Right,
it's,
right.
significantly more money. I think Eagle's like a one-time cost of like $800. Maybe not. I think I bought
Not
AutoCAD. So who
anymore.
knows?
Yeah, no, it's all different now.
Who
Yeah,
knows what it is now? But, at the
yeah.
time when we switched to Altium back in 2012, I think. And at the time, Eagle was like $800 and Altium was like $2,200 a year, right? So it's huge difference in cost from that perspective. But, if Altium saves me one day of fighting the output generation, it's worth
Hmm.
it. So
Yeah. Yeah, and I think that's standardization too. Yeah, because they have like output scripts and stuff like that, so it's always like a manufacturing package. That is
right.
probably a good like hardware analogy for it. Yeah, that's
So
cool.
the same thing with, like, like you're developing a product. Say you're, I think for Pokeball, actually, like, I always think, I think Logger is a great fit for everyone. If you're changing products every 3 months, okay, maybe the regression testing isn't as powerful, because you're not building that, you're not building up like
Yeah,
a collection of tests like you would if you're launching a Ringly and you've got like hundreds of thousands of tests, right?
right.
But there's
Yeah, I
there's
would
still
think.
the, like, go ahead.
Well, we're in the life cycle too. Is it like? I mean, in the best case, people are doing it on their first prototype, but is it like when okay, you're starting to pilot, you're doing like a build of 50, like that's when people should really be thinking about it. What is?
Again, like, and not, like, I'm obviously biased, but I think from the get go, because you're starting to build up good practices, right? Like, the first thing
Hmm.
you do when you start a new project, you download the SDK, you figure out your build system, right?
Hmm.
That build system should be inside a Docker container, which Logger gives you a bunch of tools to do really easily. And in fact, we provide a bunch of open source, but we provide a bunch of Docker images for embedded development. For Cortex M,
Hmm.
for whatever it is. And then you want to be able to if you're going to do TDD, like, that should start on day one. It shouldn't start like a year into the
Yeah.
project, where now you're like, oh, well, okay, I got the light to blink and do a bunch of other stuff. Now let me go back and write all the tests for that, right? It should.
Yeah, no, I get that. I just mean like the scale of the thing. So like if someone was doing like prototyping, like you said, if they're changing tools every 3 months because they're prototyping a bunch, that might not be a good fit. But if they were like, oh well, no, this is probably going to production or probably going to a low run, then it's like, oh well, then like when
Oh
should they
yeah, yeah,
jump in? That's the
yeah.
idea. Not that like yeah, I get the idea that they should start on day one. If they're bought in, start on day one. But if they're not bought in, how do they get bought in?
Anyone who wants to ship a product, I think that's the. So even if you're like only shipping
Yeah,
out like a few hundred, I think it's
yeah,
the
yeah. Cool. That's great. That's great. So we don't know when this episode is probably airing when there is a new site. So what is how do people find out more?
So loggerdata.com. We've got a lot of information out there about what Logger is, what it does. We've got a lot of documentation. We'll be launching a resource center pretty soon for like how do I remotely GDB into a device? How do I write a GitHub action or whatever? So just like things that people are going to want to know if they want to start using Logger. We're going to have a resource center so that it's really easy and straightforward to do, and that should go live in the next we're hoping in the next week or two. But in the meantime, you can go to our current website, and if that's like if whatever there's a delay, and we do demos. We love to do demos for people, live demos where we just I just share my screen and we just kind of walk through everything we do, and I'll ask people like is there a specific chip you want to use? We have a lot of dev boards in the office now,
Yeah,
which
yeah.
is just a room in my house, but. For the most part, we probably will have your chip, and if we don't, we'll order that dev board and do a live demo
Oh, cool.
with your actual chip.
Yeah, that's great. That's great. Well, Akbar, thanks so much for telling about this stuff. I mean, this is obviously your experience has been. It seems like this is like the natural conclusion to all this stuff. But yeah, it's 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 really good to have this focus on testing and the as much as I've heard about continuous integration in the past, I've never really understood it. I never understood how it would work for embedded. So like this is like a solid step in that direction. I feel like you're the best bet I've got for understanding it in the near future.
Fingers crossed. Yeah.
Yeah.
Well, thanks, Chris. Thanks for having me on.
Hope to have you back soon. Thanks again.